Good morning, good afternoon, good evening. Welcome to Late Night Learning. I'm your host, Dr. Anthony Palumba. Now today we're going to be continuing our discussion on appropriate measurements and scales and really thinking about different statistics that we can interpret in getting a better sense of the results of the measurements that we use, the scales that we use, and ultimately testing relationships between variables. So let's get started. So statistics, don't run out of the room just yet. I promise you it's not that bad. This portion of the lecture will be likely the toughest insofar as understanding different kinds of statistics outputs. Once you get a sense of this, it really isn't as difficult moving forward. So, statistics are used to measure for mean, median, range, and mode. Let me back up, because I know some of you are trying to recollect what you learned in high school. And so mean is the average, right? If I have numbers including 4, 6, and 8, if we add them and if we divide by them, we have an average of 6, right? 18 divided by 3 is 6. And so we also have median. Median is the middle number in a list. And so the median number of 4, 6, 8 is 6. 6 is in the middle of that list. The range is the lowest and highest numbers in a list. So for our list, it would be 4 as the lowest number and 8 as the highest. And then mode, of course, is the number that appears the most. And so we don't really have a mode in this list, but if I gave you a list of numbers that included 2, 3, 3, 3, 4, we would say the mode is 3, unquestionable. And so researchers, though we kind of try to look at things from a more complex avenue. We try to look at things from a more complex avenue. And so what we'll often do is we'll try to compare variables, as well as see if either is more predictive than the other. So for instance, I'll give you a scenario. It appears as though more men possess brand loyalty, 60% top 2 box, toward Honda than women, 30% top 2 box. But which is more predictive toward intent to purchase? And I will back up here. Top 2 box is a phrase you will hear in industry. If you are programming surveys, if you're doing any kind of market research work, you will hear this phrase. This phrase means people who tick off 4 and 5 on a scale of 1 to 5, right? People who select 4 or 5, those top 2 in a box, are what a lot of advertisers and public relations specialists are interested in. Why? Because those are the people who agree most with a statement. Those are people who may have the most brand loyalty or may have the highest intent to purchase or intent to view or intent to rent or whatever your dependent variable may be. It makes sense to look at those people. So here we can see that more men may possess more brand loyalty toward Honda, but we may be interested to see if one of the genders is more predictive toward intent to purchase, because generally speaking, if somebody has high brand loyalty, they're probably inclined to make a purchase. But that may not always be the case, so this offers us an opportunity to investigate further. Let's keep going. Bivariate and multivariate statistics. Bivariate is when we look at 2 variables. Multivariate is 2 or more, sometimes 3, 4, 5, whatever it may be. You're comparing and contrasting variables at this point. They serve to look at relationships across multiple variables. And it does allow for granular measurement. Granular measurement really gets back to our previous conversation about interval and about ratio scales, about really distilling what those differences are between each answer. It offers us precision. We're able to precisely say something about something. We get closer here. And this is why there are a lot of academics, myself included, who tend to bend toward quantitative methods. You're able to really distill distinct differences by using numbers. Of course, an argument may be made here that we don't really talk in zeros and ones. I don't ask you how you're doing and you tell me 3 or you tell me 4. That usually doesn't happen here. And so with bivariate and multivariate statistics, we're going to be starting to look at different variables. Let's keep going. Example of multivariate research study. And I know that this is a mouthful, but just bear with me. What might predict movie consumption? Call out variables that we might consider here. Take a few moments, consider what might predict movie consumption. Well, okay. A few things that might include or be a part of better understanding movie consumption may be related to previous movies watched in a genre, how many times somebody has seen an actor before, so maybe previous films that an actor has been in, how many times they viewed that actor in previous movies. Could be time of year. It could be Oscar nominations. It could be box office. It could be word of mouth. It could be what reviewers have said, what critics have said. All of a sudden, we're up to 7, even 10 variables, if we kept going, that we could incorporate here. We list variables first before we do anything, just to get a sense of the different measurements that are available to us before we just go into something. It's important to list which are independent variables, which are dependent variables. That depends on what you want your outcome to be. Are you just interested in what predicts people going to the movie theater? Are you interested in just what predicts people watching action movies or horror movies or whatever it may be? Those are your dependent variables. Again, we're thinking about the outcome. What do you want to know that impacts what? When you get to that point, you're able to better differentiate independent and dependent variables. So we run our tests, and again, in this course, you will be learning about different multivariate techniques. How do we know that something is significant? How do we know that something is significant? It's a very, very complicated question. In a qualitative sense, often, if we're running focus groups or doing in-depth interviews, we try to look for saturation. We try to say to ourselves, okay, I've seen this phenomenon mentioned, manifested several times throughout all of the focus groups. I'm going to say to myself, well, this is happening all the time. I think I've reached saturation. I think I've uncovered or unearthed some sort of theory. With quantitative work, we use mathematical modeling to get a better sense of whether the independent variable can predict variation in the dependent variable. When I say variation, that means that an increase or decrease in the independent variable is related to an increase or decrease with the dependent variable. That's what we're concerned with here. Let's keep going. So what is statistical significance? Statistical significance highlights a relationship or correlation that is very likely to occur and is not due to error. So the p-value stands for probability of error. What is the probability that there's error here, that this is random error, that this relationship really doesn't exist? That's what the p-value will tell you. It is good if it is small. We want our probability of error, of randomness, to be small. The smaller it is, this helps us understand that there is a significant relationship here. The p stands for probability of error. A significance level of 0.01 indicates evidence to reject the null hypothesis, that there is no statistically significant relationship. We reject that and accept that there is a statistically significant relationship. So, we have in the social sciences different p-values. Generally speaking, we try to look for p-values that are less than 0.05. That should be your own threshold. P-values less than 0.05. That's what's crucial here. So generally speaking, we have 0.05, we might have 0.01, we also might have 0.001. Sometimes you'll have 0.02, 0.03, those occur as well. And so we hope to have statistically significant results. If the p-value is greater than or equal to 0.05, we do not reject the null hypothesis, and we accept there is no statistically significant relationship present among the variables. So we accept that there really isn't anything significant here, and we move on. That may mean that our hypothesis is unsupported if we don't have a statistically significant relationship. Let's keep going. Qualifying statistical significance. Again, generally speaking, in SPSS output, you'll probably see 0.001, 0.01, or 0.05 p-levels. Again, we want those small because the smaller the p-value, the more likely you have a significant relationship, and it's less likely due to random error. We usually use one-tailed tests of significance. A one-tailed test just means we're testing for either a positive relationship or a negative relationship. That's all that it means. The hotter it gets, the less clothes I put on. That's kind of an indirect relationship, right? As the temperature goes up, the less clothes I wear. So I'm looking at one direction there. It's an indirect relationship. Sometimes we may run correlations or compare means. Sometimes we don't know where the relationship is. So we might run a correlation or a t-test, which you will learn later on, that helps us understand just how these relationships start. A two-tailed test tests for any relationship, positive or negative. I don't know the correlation between amount of episodes of Blackish Feud and perceptions of diversity, whatever that may be. I might have to define that. I don't know what that relationship is. I might run a correlation just to see in the beginning of my analysis how the variables vary. With the t-test, I might also compare means. I don't know what coffee satisfaction was between men and women. So I might run a t-test to see the differences between the two genders, comparing the means. But I don't know if it's going to be positive. I don't really know if it's going to be negative. I'm just simply comparing means. So that's a two-tailed test. Generally speaking, you'll be running one-tailed tests. Again, a two-tailed test is really just for correlations and for t-tests. Let's keep going. Selecting appropriate measures and scales. The last thing I'll say before we kind of start looking at output and kind of what these numbers look like in academic reports, find scales from other academic studies, scales that have been tested for reliability and validity. So reliability is the extent to which results can be reproduced, so replicable. What we're looking for are Cronbach's alpha scores. You're going to see what that means in a second. Cronbach's alpha scores. These should be, at least in my field and in most social science fields, should be 0.70 or higher. Should be 0.70 or higher. It does test for internal consistency. What does that mean? So let's say that I have, once again, a scale for brand loyalty. And in this scale, I have 4 statements in my brand loyalty scale. How much do you agree with the following statements? I don't switch from brand to brand. I will only buy this brand for the rest of my life. I am only interested in products from this brand, and I do not see myself ever switching from this brand, or whatever it may be, right? So let's say that we have 4 or 3 statements or whatever I've listed. That helps define and measure brand loyalty, right? I have my 4 statements that represent me measuring brand loyalty. If I add another indicator there, or another statement that says, my favorite color is green, is that statement related to the brand loyalty indicators or statements that I just listed? No. What does your favorite color being green have to do with measuring brand loyalty? Something like that will decrease the Cronbach's coefficient alpha score. That's what's key here. You want to make sure all of the indicators are measuring what they're supposed to measure. And so that's what the Cronbach's alpha score helps us realize. Validity. This is the extent to which measurement really measures what they're supposed to measure. So content validity refers to the adequacy with which a measure has been sampled. And so if we're trying to understand movie viewing habits, are we sampling adults or teenagers? If we sample adults, can we generalize or advance our findings onto teenagers? Probably not. So that's important to know. Criterion validity. This refers to the relationship between scale scores and some specified measurable criterion. So we may want to get a sense of how different scales compare against other scales or other measurements. What have other people measured for brand loyalty? How have people measured brand loyalty in focus groups or in in-depth interviews? Construct validity refers to testing a scale not against a single criterion, but in terms of theoretically derived hypotheses. So the idea here for construct validity is that the variables that you are using are related to the theory here that is used, are related to the underlying variable as well. And so, for instance, you want to make sure that if you're measuring for brand loyalty, that you're measuring for the specific brand loyalty that you talked about in your study. So for instance, you want to make sure that if your brand loyalty is defined as how many times you buy Yankee tickets, your brand loyalty indicators or scale should not be asking if I'm going to switch from the Yankee brand to the Mets brand. You should be asking me about how many times I purchased tickets. And so when we think of all of this, research quickly becomes very complex because you're going after the answer and you're trying to do this in a very skillful manner. Let's keep going. Interpreting correlations, finally, or maybe not finally, maybe you're turning this off right about now. Interpreting correlations. I promise you this isn't bad. And so here we're looking at motives to use social media, if memory serves right. Anyway, what we have here to the left are factors. This is a list of motives to do something using social media, And so here we have relaxation, companionship, pass the time, entertainment, information, arousal, escape, access, learning, interpersonal utility, etc., etc. And so here we can see we have each of our variables listed under motive. The number of items we see in that column, it means each was measured with 3 statements. So 3 statements about relaxation, 3 statements about passing the time, etc., etc. We have our means, we have our standard deviations, SD. That means how much variation there is in the data set. And then we have the alpha. That is the Cronbach's alpha score right there. We can see all of them are above 0.70. And we have correlations. We can see here 3 stars. 3 stars usually means 0.001 statistical significance. Are all of these motivations related to each other in a positive way? Yes, right? We can see that. Everything here correlates with each other. Now, some numbers are higher than others, but we can see here the stars. The stars indicate statistical significance here. So all of these motivations to use a particular kind of media are statistically significant. They all go up together. What does that really mean? Well, it means that if you're using, I believe it's social media, for companionship, you may also be inclined to use it for interpersonal relationships, and you may be inclined to use it for learning and access and escape and arousal. We can see here for column 1, that's related to relaxation, right? Factor 1 is relaxation. Column 1 is relaxation. As we go down the column, we can see the correlation between relaxation and companionship, relaxation and pass the time, relaxation and entertainment. Let's keep going. Interpreting Cronbach's alpha scores, again, just for you to get a sense here, you can see here that in this chart, we have different constructs. These are just different ways to measure the variable. Construct is sometimes another word for variable. We can see here in the second column from the left, the items. Those are the questions or the statements or how you're measuring things. So the first construct is attractiveness of brand personality. We have attractive, favorable, distinctive. And then as we go down, we can see how each construct or variable was measured here. And so we have the original amount of items, the amount of items necessary, and then of course the rightmost column, we have the Cronbach's alpha score. And again, everything is above 0.70 from this study. Let's keep going. Interpreting factor analysis. We will be doing factor analyses in class. So we may have like 20 or 30 brand personalities for Nintendo. Sexy, youthful, juvenile, conservative, liberal, religious, Western, masculine. How would you describe the Nintendo brand? Well, once we've done that, we can say to ourselves, well, we kind of have quite a number of statements here to help measure for people's perception. Maybe what we can do here is limit the amount of personality traits necessary to explain how people perceive Nintendo. Fine. So here you can see with the factor analysis, you can see the Cronbach's alpha scores are next to each factor. You can see that alpha A, for instance, for the first one to the left-hand side, competence is 0.96 in a national sample. In a student sample to the right-hand side of the page, you can see that it is 0.90. Underneath each factor are the brand personality traits that loaded. And so you can see for the first column, the first factor analysis is there. And we can see all of the personality traits that loaded together. For TV news, intelligent, honest, reliable, traditional, analytical, technical, secure, hardworking. Another scale that was produced here, statements that vary together and help explain the data, include timeliness to the left-hand side, up-to-date, contemporary, and experienced. As we go to the bottom, we can see here variance explained. For the first factor, 63% of the variance in the data set was explained by this. The eigenvalue is how powerful that scale is compared to an average scale. 14.48 means it is 14 times more powerful than an average scale in explaining the data variation here. So this is extraordinarily powerful. What we could do is we could use this scale to measure other channels for intelligent, honest, reliable, traditional, analytical, technical, secure, hardworking. Those seem to be the brand personality traits that are most indicative, most resemble, most explain TV news channels. So we could use that for Fox News, MSNBC, CNN, what have you. Let's keep going. Interpreting ANOVAs. We will be getting into analysis of variance. We will be getting into ANOVAs here. An ANOVA is usually used in experiments because we're trying to tell and pull apart differences between groups. And so here we're looking at audience group differences on age, education, and income. And so we have three groups here: non-interactive audience, average audience, and interactive audience. Those are three audiences, and what we're trying to do here is we're trying to see differences. And so we can see here for age, we have our number of participants, 31 for non-interactive audience. We have a mean, we have a standard deviation, we have degrees of freedom, which you don't need to worry about, and then we have an F-test. The F-test or F-score will tell you how different the groups are versus how much differentiation exists within each group. You want a high F-score. It will tell you that there are big differences between each group. That's all you need to worry about here. You can see here age is very different here. We can see here that the age is split up across interactive audiences. So how interactive audiences are appears to be determined in part by age. Fine. With education, we don't see a statistically significant difference, right? There's no star next to 1.06 under the F-test. And then for income, we see a statistically significant difference here. Average audience and interactive audience appear to earn more income, though we don't know this. If we need to know what the probability of error is, we just go to the left-hand corner. As always, you will find the p-value and what that star means. Let's keep going. Finally, we have regressions here, and I appreciate your patience with this. I know this stuff is complex, but it is useful once you get your mind wrapped around it. Regression analysis predicting emotional response. So this uses variables to predict emotional responses among sports fans. And so what we can see here is we have positive emotions as a dependent variable. We have negative emotions as a dependent variable. And we have touched emotions as a dependent variable. Now, I don't have the study in front of me, and so I can't tell you specifically what touched emotions is defined as, but positive and negative we can look at for the purpose of this exercise. So on the left-hand column, we have all the independent variables: game type, final point differential, win for favorite team, baseball involvement, athlete affinity, suspense, hedonic enjoyment, and appreciation. And so here, if we look at the first column, positive emotions, which variables are most predictive of positive emotions? First, we can see win for favorite team, right? 0.19, it has the stars. Anything with stars means that there's statistical significance. We also see hedonic enjoyment, just a lot of pleasure, a lot of fun. And then we also have appreciation. Again, we'd have to see how these are defined, but we can see which variables stick out, don't we? We can ignore the rest. R squared means the amount of explained variance from these three variables. These three variables explain 67% of positive emotions in this data set. That's pretty high, and that's exceptionally remarkable. If we go to the second column, we can see here for negative emotions, win for favorite team has an indirect relationship, right? Anything with a negative means there's an indirect relationship. So we can see that the worse your team does, the more inclined you are to have negative emotions, right? There's kind of a negative or an indirect relationship there. The worse your favored team does, if your favorite team loses, you are inclined to have high negative emotions. That's why there's a negative sign there. We can see for hedonic enjoyment as well, the less fun you're having watching sports, the more likely you are to have an increase in negative emotions. And we can see here 0.54, 54% of explained variance in negative emotions in the data set is explained by those two variables. Again, at the bottom, we can always see what the little stars and crosses mean for each particular p-value. Let's keep going. I recognize that you guys are still up with me. It's just one more slide. I promise we'll be done soon. I know this is a lot of information for all of you, but this will make sense to you over time. This is a regression analysis for predicting appreciation, but it is done in steps. So a step regression, because we just saw a regression, normally you test all of the variables at once. Here, this is a step regression, stepwise regression. And so what we have here is in the first step, we have game type, final point differential, win for favored team, suspense, and hedonic enjoyment. You see that in the first column, right? In the second column, we see two more variables are added: baseball involvement and athlete affinity, right? Baseball involvement in the second B column is 0.15, and athlete affinity is 0.18. They were not used in the first step, in the first column, but then they're added. Then we do it a third time in predicting appreciation, and we have virtual friendship and respectful interest. Now, at the bottom, we have change in R squared. So in the first column, those three variables explained 62% of appreciation in that data set. When we go to the second column, we can see, because the triangle next to R squared in the bottom row means that there's a change. We see a 0.06 and then a 0.68 underneath it. 6% more explanatory power was added when we included baseball involvement and athlete affinity. And then there appears to be no change that was made in the third column. And so you can see here that there's quite a bit about statistical significance and trying to figure out how variables work and operate and things like this. It's very complex, and it does take some practice, and it does take some effort in going over this stuff and getting comfortable with the material. I am sure some of you are lost. I'm sure some of you think you can't do this. I'm sure some of you are dreading everything right now. I promise you, I was in your position in grad school. I was in your position the first semester of my doctoral degree. I was taking Statistics 1, and then in the summer or in the spring, I took Statistics 2, and then I took an experimental statistics class. I've taken 3 stats classes. It's building and building and building and going through things over and over again. It's not easy, but bear in mind that this is a process, that you are at your worst now. You are the worst you will ever be at media analytics, and that should make you happy because you will be working on this, and I promise you, you will be getting better at this. That's all the time we have on Late Night Learning. As always, keep laughing and keep learning.